Hey guys, you guys weren't expecting this one, alright? Y'all weren't expecting this one, but your boy got a sponsor. So we're gonna get right into that in a little bit. Oh, hey, Cool Gio, you're back in here again. That's a surprise. And where are your shades? You know what? It's okay, Cool Gio. Let me ask you something. Have you ever heard of something called GitHub and go login? Come on, Gio, ask me about it. You know you want to. I am so glad you asked, Kojio. GitHub is the world's largest database of technical knowledge. Over 400 million repositories, developers, startups, open source community. Everyone stores their codes here. And buried inside those repositories is data that's incredibly valuable. Which technologies are gaining momentum right now? Which projects are growing fastest this month? Which tools are developers actually using, not just mentioning Twitter? All of that is accessible through GitHub Scraping. But if you, yes you, try to do it manually, even 50 repositories will eat up several hours. Every week, that's a long time, isn't it? And by the time you reach the end from the list, everything has already changed. I'm going to show you, yes you the viewer, you're looking real nice today, keep it up, keep it up. A complete guide to GitHub Scraping. From scratch, step by step, even if you never written a scrapper in your life. Watch to the end. I'll show you how to set up Go Login for clean scraping. I'll show you how to connect proxies properly and how to verify your browser isn't visible as a bot before you start collecting data plus. But between me and you, a link to 2 free gigabytes of proxies is in the description. GitHub Scraping means automatically extracting specific data from repository pages. Let's break down exactly what's worth collecting and why. Stars. Think of them as bookmarks. The more stars a project has, the more popular it is. If you track down star growth over time, you can see which technologies are gaining traction right now. That signal is more reliable than any other analyst report. Forks. How many times someone copied the project to build something of their own? A high fork count tells you the code is being actively used as a foundation for other solutions. Issues, bug reports, and feature requests. Scrapping issues shows you what problems users actually run into with a tool or framework. That's invaluable data for product teams and market analysts. Commit frequency and content tell you how actively a project is maintained. A repo with its last commit 3 years ago is a completely different story from a project with daily updates. The project description and setup guide. A well-written README is the first signal of a mature project. Who actually uses this data, you might be asking? Well, beautiful, kind-looking viewer, I'll tell you right now. SEO specialists to identify trending developer tools for tech blogs. Venture investors to spot fast-growing open source projects before TechCrunch writes about them. Product managers to monitor competitors. Data scientists to build data set about the state of the tech ecosystem. Hey, Future Geo here. Just wanted to remind all of you that everything you're seeing here is all publicly accessible data, even before scrapping at a scale. And don't forget to check the platform's terms of service and the robot text files. This just tells automated tools what pages they're allowed to visit. So don't scrape private repositories and don't hammer servers with thousands of requests per second. GitHub Scraping automatically pulls stars, forks, issues, commits, and readme data from public repositories. Alright, now back to the video. Here's the point where most beginners get tripped up. I want to explain it as clearly as possible. When you open a repository page in your browser, you see everything at once. Files, commits, stars, contributor activity. Hey, Future Geo here again. Back to explain some more of this. GitHub uses dynamic rendering. The page first sends you a skeleton and HTML shell. Then JavaScript, the code running inside your browser, loads the rest of the content. The commit graph, contributor stats, and certain activities all show after the initial load. Now, I know what you're wondering. What happens if you use a simple HTTP tool like Python's request library? Well, you only get that skeleton. Everything JavaScript loads in afterwards stays completely empty. And so your scrapper will return blank fields where you expected data. Still don't understand it? Okay. Think about it like this. An SEO specialist wanted to track open source project activity for a tech blog. He wrote a simple request script. Stars and README worked fine, but the commits, they came back, well, empty. Why is this? Because they load dynamically. The script couldn't even see them at all. The solution is simple. A browser-based approach that actually opens the page and waits for JavaScript to finish. That's how Playwright, Puppeteer, and Selenium work. They control a real browser rather than just downloading in HTML. GitHub loads some content dynamically with JavaScript. Simple HTTP tools miss it entirely. You need a browser-based approach. Now, time for everyone's favorite, real code. I'll show you 4 levels, starting with the simplest approach, of course. Then why it breaks on dynamic content, then how to fix it, and finally, I'll show you the right setup for scrapping at a scale. Level 1, fast but limited. This works for static elements, the respiratory description, README, but try adding a line for commit messages and, well, you'll get none. Because commits are loaded by JavaScript after the server's first response. Requests, they just simply can't see them. Level 2, Selenium. A real browser solves the actual problem. The key line is driver implicity, wait 10. We're telling the browser to wait 10 seconds for JavaScript to load the dynamic content. After that, page source contains the fully rendered HTML, including the commits that request couldn't see. Okay, so at this point, we'll add a proxy directly into the script. This mostly matters when you're working with hundreds of repos instead of just one. Level 4. A regular Chrome launched by Selenium has a standard, easily recognizable fingerprint. Anti-bot systems see it immediately. When you're crawling hundreds of repositories, you'll get blocked. But not by IP, but by fingerprint. This is where GoLogin and Selenium work together. GoLogin launches a profile with a unique fingerprint and a residential proxy. And Selenium connects to that already running browser through a debugger port. And your script gets a fully controllable browser like it's a real person. This is how Selenium jumps into the already open GoLogin browser. It doesn't just launch a plain old Chrome. It connects to a GoLogin profile with its fingerprint, proxy, and isolated session, all already in place. GoLogin uses its own Chromium engine called Orbita, and the Chrome driver version needs this to match. This line automatically fetches the correct version. So you're using a real browser, probably what you're using to watch this video right now. Well, here's the second problem. When you open pages automatically, even in a real browser, the website can detect that your traffic doesn't look like a human. It reads your browser's fingerprint, a unique ID card assembled from dozens of parameters: screen size, installed fonts, graphic card data, canvas and WebGL, signatures, time zone, language, and much more. If these signals don't align, for example, the user agent says Windows, but the font rendering behaves like Mac OS, the anti-bot system flags the inconsistency. Regular browsers running in headless mode without a visible interface are especially vulnerable. They have characteristic fingerprints that detect systems recognize quickly. Now this is where an anti-detect browser comes in. It's a specially modified browser that masks or spoofs fingerprint signals. And this creates isolated profiles with unique identities. And this also lets you attach proxy to each profile separately. According to GoLogin's own documentation, modern anti-detect browsers include hardware fingerprint simulation, and that's when your real IP leaks through the proxy, machine learning based behavior and pattern mimicry, and API with integration and automation tools like Selenium and Playwright. For GitHub specifically, this matters at scale. When you're crawling hundreds of repositories, rate limiting and anti-bot systems beginning to block requests that look automated, an anti-detect browser, and an IP from a real home internet provider looks like a normal developer browsing through repositories. An anti-detect browser masks your ID card, but not only that, it isolates each scrapping session. Without it, you'll be blocked scaling up. We just saw the GoLogin and Selenium code. But before that script can work, you'll need to set up the profile inside GoLogin itself. And there are 3 required steps. GoLogin is an anti-detect browser built on its Chromium engine called Orbita. The key thing about it is that it doesn't make you manually configure dozens of low-level fingerprint parameters, and it automatically generates a realistic, internal, consistent profile. By doing this, it reduces the chance of mismatches, and which are exactly what trigger detection systems. Now, step 1, create a profile. Open GoLogin and you'll see profile list on the left. It's empty for now. Click the blue add profile button at the top. A panel opens. Type a name. I'll call mine GitHub Research. Step 2. Connect the proxy. You'll see a proxy field in the profile settings. Paste your residential proxy credentials here. Now, you might be asking, why residential? A residential proxy is an IP from a real internet provider, not a data center. It looks like you're browsing someone's home internet instead of a server farm. And remember, anti-bot systems check IP type first. Now click proxy. If everything is correct, you'll see a green check mark in the proxy's country. If you get a red error, double check the credentials. A straight space often leaks in during copy and paste. Step 3. Create and launch. Don't touch time zone, language, or location. GoLogin automatically reads the proxy geolocation and aligns all parameters to match. This matters because a mismatch between time zone and IP location is one of the most common things that flags automation. Now click run. A browser window opens. This is your isolated scraping environment. Step 4. Verify the fingerprint. Before going to GitHub, open a new tab and navigate to epay.com. This is a fingerprint verification tool. It checks exactly the same signals that anti-bot system check. IP type, fingerprint consistency, WebRTC leaks, time zone to IP match, all green. No leaks. That's what you need before starting. GitHub's anti-bot systems read those exact same signals. If ePay shows clean, then the system sees it too. If ePay shows a red warning, go back to GoLogin, click the refresh icon next to the profile to regenerate the fingerprint, and run again. Now navigate to any public GitHub repository. You'll see the full page, files, readme, stars, forks, everything. This browser window is the environment your script connects to. The profiles, fingerprint, and proxy are locked in. Every request from this window carries the same clean identity. A data analyst monitoring the top 200 ml repositories weekly ran Selenium with irregular browsers with no proxies. After about 80 pages, GitHub started to return rate limit errors. That's a temporary IP block. With a GoLogin profile and a residential proxy, and the request looked like a normal developer browsing through repos. Profile created, proxy connected, fingerprint verified green on ePay. Well, my friend, you're ready to scrape GitHub. Even with a clean profile, you'll get blocked if you request pages too fast. Here's what different types of blocks look like so you can recognize them. Rate limit. This shows up as an error page or an empty response after too many requests and a short delay. In your browser, you might see a page that says rate limit exceeded, or just an empty result with no data. GitHub uses these less aggressively than some other platforms, but at high volume, you will encounter them. Soft block. This is the sneakiest one. The page loads normally, but the data is stale, empty, or suspiciously identical across the last several pages. Your scraper thinks it's working. It's not working. Here are the pacing rules. Randomize delays between page loads 3 to 6 seconds, different each time. Always test on 10 pages first, and check that the data looks complete and fresh. Residential proxies cost more than data center proxies, roughly 3 to 5 times per gigabyte. That's the price for looking like a real person, rather than getting blocked on the first batch. There's no cheap shortcut for a platform that tracks IP reputation.
Request is enough. I don't need a browser.
In reality, GitHub dynamically loads commits, contributor stats, and activity feeds through JavaScript, and requests won't see them. You'll get incomplete data that look like successful requests until you check the actual values, and they're not.
Free proxies are fine.
In reality, free proxies are shared by hundreds of users simultaneously. Their IPs are already flagged. They're slow, unreliable, and some log your traffic. And to be honest, for anything beyond 10 test pages, they're useless. More requests means more data. In reality, past a certain speed, more requests means rate limits and soft blocks. And you don't want that. You'll get empty responses that look successful. Page scraping with randomized delays collects more data than brute force volume. And here's a quick reference sheet. You done yet? Okay, so here's everything we covered. And if you want to replicate this GitHub scrapping setup, a link to go log in and 2 gigabytes of free proxies is in the description or in my pinned comment.
And between me and you, it's 40% off with my link.
Now, if this helped you, click like. Any questions? Put them down in the comments. As always, Gio was here, and I'll see you guys in the next one. See ya. Alright, cool, Gio. I know that was a lot, but did you get all that? Cool, Gio? Cool, Gio?
Where the freak did he go?